All living things are made of carbon. Carbon is part of the ocean, air, and even rocks. Because the Earth is a dynamic place, carbon does not stay still. It is always on the move. The carbon cycle comprises a sequence of events that are key to making the Earth capable of sustaining life. It describes the movement of carbon as it is recycled and reused throughout the biosphere. Carbon-based molecules are crucial for life on Earth because it is the main component of biological compounds. In the atmosphere, carbon is attached to some oxygen in a gas called carbon dioxide, which is also known as CO2. Carbon dioxide is partly responsible for the greenhouse effect, and it is the most important human-contributed greenhouse gas. The global carbon cycle is divided into the following major reservoir of carbon: the atmosphere, the terrestrial biosphere, the ocean, which includes dissolved inorganic carbons and living and non-living marine ecosystems, the sediments, which includes fossil fuel, freshwater systems, and non-living organic materials such as oil carbon, the Earth interior, carbons from the Earth mantle and crust. These carbon stores interact with the other components through geological process. The ocean, which contains the largest active pools of carbon near the surface of the Earth. The natural flow of carbon between the atmosphere, ocean, and sediments is fairly balanced, so that carbon levels would be roughly stable without human influence.
The phrase carbon cycle is used to describe how the carbon in the environment flows among living beings, inorganic matter, and the atmosphere. The path that carbon follows as it cycles through the air, earth, plants, animals, and fossil fuels literally defines life as we know it. Large amounts of carbon exist in the atmosphere as carbon dioxide. Carbon dioxide is cycled by green plants during the process known as photosynthesis to make organic material. This is where the nourishment of every heterotrophic organism comes from. Animals do the opposite of plants. They release carbon dioxide back into the air as a waste product from respiration. Decomposers, when they break down dead organic matter, release carbon dioxide into the air also. Decomposers are essential because without them, all of the carbon on the planet would eventually become locked up in dead carcasses and other trash. Decay allows carbon to be released back into the food web. Carbon is also stored in fossil fuels, such as coal, petroleum, and natural gas. When these are burned, carbon dioxide is also released back into the air. Volcanoes and fires also release large amounts of CO2 into the atmosphere. The ocean plays an important role in the global carbon cycle. Carbon moves in and out of the ocean daily, but it is also stored there for thousands of years. Carbon dioxide can dissolve in water, where some of it is later returned back into the atmosphere. The rest can be taken to form calcium carbonate, which builds up shells, rocks, and skeletons of protozoans and coral.
The carbon dioxide content of the atmosphere is gradually and steadily increasing. The graph from the CO2 concentration at the summit of Mauna Loa in Hawaii from 1958 through 2006. The values are in parts per million. The seasonal fluctuation is caused by the increased uptake of CO2 by plants in the summer. By the spring of 2012, it's expected to have risen to 397 parts per million. The increase in CO2 probably began with the start of the Industrial Revolution. Samples of air trapped over the centuries in the glacial ice of Greenland show no change in CO2 content until 300 years ago. Since measurements of atmospheric CO2 began in the late 19th century, its concentration has risen over 20%. This increase is surely caused by human activities, such as burning fossil fuels, which return to the atmospheric carbon that has been locked away within the earth for millions of years. Clearing and burning of forests, especially in the tropics. In recent decades, large areas of the Amazon rainforest has been cleared for agriculture and cattle grazing. In the past 2 centuries, human activities have seriously altered the global carbon cycle, most significantly in the atmosphere. Although carbon dioxide levels have changed naturally over the past several thousand years, human emissions of carbon dioxide into the atmosphere exceed natural fluctuations. Changes in the amount of atmospheric CO2 are considerably alter weathering patterns and indirectly influencing oceanic chemistry. Records from ice cores show that, although global temperatures can change without changes in atmospheric CO2 levels, CO2 levels cannot change significantly without affecting global temperatures. Current carbon dioxide levels in the atmosphere exceed measurements from the last 420,000 years, and levels are rising faster than ever, making it of critical importance to better understand how the carbon cycle works and how its effects are on the global climate.
Carbon can get into the atmosphere from soil, decomposing animals, waste product, burning sediment from the earth, or events like a volcanic eruption. The carbon cycle, as we know now, encompasses the whole world and plays a critical role to our Earth. Humans are changing the carbon cycle, and it could have dangerous effects to life on Earth. Large amounts of carbon are being released daily, and more trees are being cut down, therefore increasing the amount of carbon into our atmosphere because the number of trees which absorb carbon to produce oxygen is decreasing. When more carbon dioxide is released into the atmosphere, it increases the level of greenhouse gases, increasing the greenhouse effect, trapping heat into the planet and increasing global warming. Global warming is causing the climate to increase, therefore glaciers are melting and the sea levels are rising. If we do not decline the amount of carbon emissions, we will see drastic changes in the near future.